Right, so let's give it a good look. So they say a cone with a radius r centimeters and a height AB is inscribed in a sphere with center O and a radius of 8 centimeters. Then they say OB is equal to X. Do you know what's the meaning of the word inscribe, sir?
I think it's placed in that sphere.
But how is it placed? Is it just placed randomly or?
This place so that it can fit in all the corners, I think.
What's
I
the
think
meaning of
it
it can
can
fit
touch
all the
all the sides
corners?
of the.
Thank you, sir.
I
Yes, the
mean,
vertices,
uh,
they're exactly on that circumference. Okay, sir. So a cone with a radius r centimeters and a height AB is inscribed in a sphere with center O, okay, and a radius of 8 centimeters. So 8 centimeters is the radius of the sphere. Then they say the length of OB is X. They give you the volume of a sphere. They also give you the volume of a cone. And then they say, please find the volume of the sphere and also show that r squared is 64 minus x squared. Okay, let's quickly deal with those. But firstly, I really need to see this. I like visuals, so I'm going to spend 1 minute at best to quickly draw the diagram here. And I'm saying quickly because I know that I won't be done in 10 minutes time, imagine. But yes, this is the sphere. And in this sphere, they say we have a cone that is being inscribed. Well, this is our nice cone. I'm really glad, so you know, mathematical language. There are people who are lying out there. They're busy saying mathematicians, they don't know English. That is a big lie, sir. So I'm glad that you are defying the odds. Is it really the odds? Well, I'm not sure, but nonetheless, I'm really proud of you, sir. Mathematicians, they must be good at English because English is a language of communication, sir. Otherwise, when you teach people, you'll be saying, if you take this and you mix it with that, you multiply it by that, then you can get a 5. What are you saying? You need to give us a bit of a terminology when you speak maths. Okay, so here they say the center of this sphere will be somewhere here. Well, that's fine. And of course, this will be the radius of the sphere itself, which is from here to there. And then they say, well, this one, it's just going to be something that looks a little bit like that, if I may. And of course, here we'll just be having OB, which is just a nice length there. And then they say, well, this one is the radius of the sphere as well. So it will be equal to that. Okay, fine. Now, furthermore, what is it? We know that this is A. We don't know what's the point there. I see you gave it a name, but we don't really need the name. Then here they say it's B and this is O. We know that OB is X units and AO, which is the radius, that is 8 centimeters. And this is the radius as well. So it's going to be 8 centimeters. Then they told us this is a 90-degree angle. This is beautiful. Okay, fine. Then they say, oh, very important. How can I miss this? Well, they say the distance from B to P, we just call it R, is it? Okay, I'm missing something. Okay, so this small r that you see here is actually the radius of the cone. I need to respect it and write it in black. So Yes. Yes, yes, yes. It's the radius of the cone, the pink one. Please don't confuse the two. Okay, fine. Well, this one is actually not there, but nonetheless, yeah, this part is not really there. So maybe I can just, I don't know, undo it. Fine. Yeah, no, I don't need to replace that white. Okay. The first question is asking for the volume of the sphere, and this is just for 1 mark. And the reason for that is you only need to know the radius of your sphere, and then you are fine. In this case, we know that the radius of the sphere is, what is it anyways? 8 centimeters. And we know that in order for us to find the volume of a sphere, it's actually 4/3 of pi r cubed. Pi is a constant, the radius is 8, and it's cubed. And if you go to your nice and beautiful calculator, you find that the volume will simply be 4/3/8 cubed. And I'm just going to keep it in fraction form. It's simply going to be 2048 divided by 3. And then, of course, this is multiplied by pi centimeter cubed. Please add the unit as well. Well, let us walk in a path. Then the next question is also for a single mark or a unit mark. When you get to university, you'll learn that unity is 1. Well, of course, you know that the magnitude of unity is 1. So, what am I saying? I'm saying this question is for a unit mark, which means 1 mark. It says, please show that r squared is 64 minus x squared. Well, that's fine. So this is our r, which is the radius of the cone. And x, we know that it's the distance OB. And 8, well, 8 is the radius of the sphere itself. But we can see that those three sides are forming a right-angled triangle. And according to the theorem of Pythagoras, the square of the hypotenuse is equal to the sum of the squares of the two other sides. Please give a reason for your answer. The grounds on which you are basing this is the theorem of Pythagoras. Well then, making r squared the subject, the square of 8 is simply 64. And then you say, well, this is just going to be 8. But that's fine. Now, this one was not difficult to understand, hopefully. This is the main question. So here they say, determine the ratio between the largest volume of this cone and the volume of the sphere. We know the volume of the sphere, we just found it. But the question is looking for the ratio between the largest volume of this cone and the volume of the sphere. And we are good mathematicians. We know what's the meaning of the word ratio. It means if you take the volume of the cone and you divide it by the volume of the sphere, that's the meaning of the word ratio. Two things divided by each other. But now, we don't know what's the volume of the cone, but we want to find the largest volume, which means we are maximizing the volume of the cone. That's the first thing we need to do. Okay, fine. So, how do we deal with this? That's a good question. Well, let's begin by defining the volume of a cone. We know that the volume of a cone is defined as 1 over 3 pi r squared height. That is what we know. Yes, they gave it to you, but of course that's how it's defined. Now, we can say that the volume is expressed in terms of two variables, the radius r and the height h. We don't know both of those, but we want to express it in terms of one variable only. And the best variable in which we can express it is x. We know what is r squared. Every time we see r squared, we say 64 minus x squared, which means I just need to express the height in terms of x as well. And as a matter of fact, I can, because the height of the cone is simply going to be the radius of the sphere added to that distance OB, which is just x. So what does it mean? It means my volume as a function of x is just going to be 1 over 3 pi. Where I see r squared, I put 64 minus x squared. And where I see the height, well, I'm simply going to put x plus 8. This is how it works. Then, of course, from this point, I simply need to expand, because according to the rules of differentiation, I can't differentiate for as long as I have brackets, yes? So I'm just going to do this aside and just plug it in. According to the FOIL method, we take 64 and times it by x, take 64 and times it by 8. Well, I'm just going to press this into my nice calculator, which was given to me back in 2019. Then next we say x squared by x, that's negative x cubed. Oh, we don't really have like terms to collect, so I might as well go on and say it's 64x for this one, 512 for that one, negative x cubed, yes, and negative 8x squared. Well, this is what I'm going to get. Just to verify, because I have a PhD in making mistakes, 64 by x, yes, by that, yes, negative x squared by x, and of course by 8, perfect. And now it's time to distribute the constant. So then, I'm simply going to get negative 1 over 3 pi x cubed. Then I get negative 8 over 3 pi x squared. Well, 64 is an even number, so is it really divisible by? No, it's not. So we have 64 over 3x. And lastly, we have 512 divided by 3. Well, this is what we say. Then what's the next thing? We now need to find the derivative. We are looking for the maximum volume, the largest volume. So we need to differentiate. According to the power rule, 1 over 3 times 3, they will cancel out and I simply get a solid pi x cubed. Then here I say 8/3 times 2. Well, I simply get 16 pi over 3 x. And lastly, I get 64 over 3. Well, this is what I get. Next, I'm going to equate my, is it not x cubed? What do you mean, sir? Oh, it should be x squared. Thank you so much, Simon. I really appreciate the eyes. Yes, I'm an old man, so I really appreciate the young eyes. Okay. Yes, the next step is to set the derivative equal to 0. That's fine, I can redo it. So I still have negative pi x cubed, no, x squared actually. And here I'm just going to have negative 16 pi over 3. And then we say negative 64 over 3. Yes. So well, let's destroy the fraction first, because it's really easy to deal with this if we don't have a fraction. So this means I'm going to multiply throughout by negative 3 pi. And since everyone has a pi in them, not really by negative 3 pi, but by negative 3 over pi. Do you see that? So that the pi's in the numerator will be cancelled by the pi in the denominator. And the 3's in the denominators will be cancelled by the 3 in the numerator. That's what I'm trying to say to you. So, yes, that's what I'm saying. Well, does the 64 have a pi? Of course it should. It should have a pi there. It really should have a pi. As well as the 512 over 3. It should have a pi. Everyone must have a pi. Okay, it's a pi day. Sorry for forgetting the pi. Okay, now we move on and we say after multiplying that, remember we multiplied by negative 3 over pi. So that here we get 3x squared. And here we get positive 16x. And here we get positive 64. That's what I'm saying to you. I'm not going to show the quadratic formula, but I'm going to substitute into my quadratic formula in the calculator and just get the thing. So everything is positive in the numerator. Okay. I hope it doesn't backfire. It really did backfire. Hey, man. Okay, it means I made a mistake with a sign somewhere. Where is that? Well, the first two terms are supposed to be positive, which means 512 over 3. Yes, it is positive. Okay, I made a mistake on the... Okay, no, we can find that mistake and fix it. This one by that, yes, it's positive. This one by that, positive. So the one with 64, it should be positive instead of negative. All right? Yes, positive. That one is now gone because the negative terms should be negative x cubed, yes, as well as 8x cubed, okay? Yes, as well as that one. They should be negative, but the other one should be positive. Okay. So then when we divide by a negative that or multiplying by negative that, the last one should be negative. Okay. So when we now go back and fix this error, then we find that the value of x can be 8/10 or it can be -8. there's no way that x can become negative. So you know that we simply have to cancel it because x is, in this case, it's that distance OB. Does it make sense for a distance to become negative? Yes. So now that we know our value of x, then we need to find the exact value of the volume because at the end of the day, we want to find the ratio. So now we can go on and say the volume of a cone is 1 over 3 pi r squared times the height. But you know what is r squared? R squared is 64 minus x squared. So here we have 64 minus x squared. Then we times this by the height. And the height is x plus 8. So it's 8/10. And this is added to 8. And when you now go to your nice calculator and say 1 over 3 pi, 64 minus 8/10 squared, and this is multiplied by 8/10 plus 8. Oh, here they give it to me as a fraction, but that's fine. So it's going to be 635.4549 centimeter cubed. And now I need to take this volume of the cone. And I divide this by the volume of the sphere, which I found initially as 2048 over 3 pi. Well, I'll just write it here, 2048 over 3 pi. Well, that's fine. Hopefully we get a solid number. Then when you now go to your calculator and say this thing divided by 2048 pi over 3, you are simply going to get 8 over 27. That is the ratio between those two volumes. Yes. Yes, that is it. I'm really sorry for making mistakes with the sign here. Please do find it in your precious heart to forgive me. And yeah, that's how you do it.